This meeting is being recorded.
Hi all, this is Team 19 and the team members are Achyut, Varshik, Kaustubh, Harshit and Rajiv. And our project is COVID-19 Trends Analyzer. The COVID-19 Trends Analyzer discusses how we use heterogeneous sources and data sets, for example, from Kaggle and GitHub, and how it can be processed into RDF and entryable format backed by an ontology in order to make it accessible to semantic web tools application and enhance the decision making within autonomous smart agents. This data is further used in order to show visualizations of the COVID-19 trends across the states of India, and we show data like active cases, deceased, recovered cases in the form of visualizations.
Hi, this is Kaustubh. I'll be talking about the project structure. So in this project, what we've done is we have used the Apache Fuseki server for hosting all our semantic data in the form of entriples. And we have a front end that is built using React. And we also have a backend that is responsible to fetch the data from the Apache Fuseki server. So the backend is developed using Flask. And to actually connect with the Fuseki server, we used the requests API present in Python. So using that, we fetch the data and then we're relaying it to the front end. As part of the architecture, what we've done is we have containerized the whole application. So we have different containers for the front end, the back end, and the Jira Fuseki server itself. And the deployment, we have split the deployment into two parts. One, the front end is being deployed on Netlify, and the Fuseki server and the backend, that is the Python backend, are deployed on Amazon EC2 instances. Over to you, Varshik.
Hi, I'm Varshik. Coming to ontologies, we are using four main classes: states, districts, state codes, and district codes. And the object properties are has district code, has district name. These are the object properties. And has districts and is district of is an inverse property, and the rest are functional properties. Coming to the data properties, we have one data property for each of the confirmed active cases, deaths, name, recovered cases, and in state. And we have used selfie prodigy to generate the entryable format for the data. And these are the transformation rules we have used to generate the data. This in total we have used four transformation rules to generate the data, and this is the queries we have run in the code. Due to the time constraint, I not able to show all the queries, so I will give you a sample run of some of the queries. This is the query to get all the districts with all of the confirmed cases, active, recovered, and deaths. As you can see, we got the data for all the districts with all the number of active cases, the number of confirmed cases, and the deaths. Next, we'll run a query to get. Next, we'll run a query to get the district-wise data for a particular state. As you can see, these are all the districts present in the state Telangana, and you can see the data for all the districts. And
hello, I'm Achyut. So I'll just demonstrate about what we built. So this is the interface we built. We use React, and you see the visualizations are built using 3JS and D3JS. The table you see here is being populated from running SPARQL queries on the n triples, which is fed into our Fuzzy server, and it is served from Flask, and we hit the API endpoints, and that is how we get this data. So as you see, this is not just CSV data; it's a time series data, which is much complicated than regular CSV data. So as you see, on our first visit, we make a query from SPARQL, and we get a response here, and we populate this particular table here. So we have the data details of all states and the confirmed cases for each state, active cases, recovered, and deceased. So also we have the data for district, all the districts, the confirmed cases, active, recovered, and deceased. So back to states again. So as you see here, as we click the state, we display the districts that are part of the state, and we also fetch that particular data from our backend. And then so you click here to see more details. We generate the map of the particular state, and also display the stats for that particular state. So coming to the challenges we faced, we had a lot of too much the data was humongous in our case, because as you see, it's a time series data. We had around 4 lakh rows of data to run queries from. So given the uh, time constraint, a challenge, and limited resources, we came up with a proof of concept to demonstrate our understanding, and we implemented it by coming up with the architecture, like my teammate explained you earlier. And going to the future scope, we planned to even work with the time series data in such a way that we come up with multiple workers. So we split the data and then parallelly run ontologies and generate n triples, so we can run SPARQL queries on them, and then we feed it back to the front end, and we can get the visualizations as you see here. But few of them are done on JSON, because currently we are not able to generate ontologies and n triples for the time series data in particular. So I'll pass on to Harshit.
Hi, this is Harshit. So the roles and responsibilities of the project are goes like the application development is done by Harshit and Varshik. Ontology creation is handled by Sai Kaustubh and Varshik. Data pre-processing and converting to n triples is done by Rajiv. Loading Apache Gina Fusky with triples is done by Rajiv and Harshit. Containerization is done by Achyut and Sai Kaustubh. API development is done by Achyut and Rajiv. Thank you.
So before we conclude, we also wanted to talk about the deployment part. So like I said, we deployed the containers, the Fuseki and the API server containers on Amazon AWS EC2 instances. We also have the data set, the OWL file that we have created as part of our GitHub repository. So if you are interested, you could go into the repository and check out our data. Yep, that is pretty much what we have done in this project. Thanks a lot.